Hi there, welcome back. I'd like to show you how to do a problem using rotational kinematics. This is a pretty simple problem. We've got a spinning wheel of a car with a radius of 0.35 meters. It makes a number of revolutions per second. We want to know how many revolutions per second the wheel will make when the car has a velocity. This is a linear velocity of 20 meters per second. So, and the second question is, how many radians per second is it? So to begin with, think about a wheel. As the wheel spins, it moves with an angular velocity, omega, and as it moves along in a straight line, it moves with a linear velocity, v. And in this problem, that's 20 meters per second. Now, to get omega, omega is a rotational velocity. It is how many radians per second, how many degrees per second, or how many rotations or revolutions per second the wheel makes. So it's relating angles, a rate of angular movement. So, a couple things to know from the beginning. One revolution around a circle is going to be 2 pi radians. It also happens to travel a distance of 2 pi r meters, if we're measuring in meters. So since this wheel has a radius of 0.35 meters, once we put in meters for r, we're taking a number with no units times meters, so that's going to give us a circumference in meters. And this is also equal to 360 degrees. So I can say one revolution is 2 pi times the radius, 0.35, and that's going to give me, what is it, 7 tenths pi, 7 pi over 10, or if you work that out on a calculator, it's about 2.2 meters. Okay, so one revolution of our car's wheel will travel a linear distance of 2.2 meters. Well, I can now make a little conversion here. If I have 20 meters per second, one revolution is 2.2 meters. Notice I have meters in the numerator, meters in the denominator. They'll cancel, and I'll be left with revolutions per second. So another way to think about this is, for every 2.2 meters, the car goes 1 revolution. So 20 meters per second is going to be, well, what is it, 9.1 revolutions every second. So that's an answer to the first question. How many revolutions per second does the wheel make when the car has a velocity of 20 meters per second? I'm going to show you a second way to do that, by the way, but first let's find this second answer. How many radians per second is that? If I have 9.1 revolutions per second, and each revolution is 2 pi radians, then I can say 2 pi radians for every 1 revolution gives me about 57 radians per second. So this is two ways to write omega. Those are both expressions of an angular velocity, omega. Revolutions per second, radians per second. And they're related to each other by 2 pi. Okay, by the way, I'm sorry, that is not 91. I misread my note. That is 9.1. Boy, I should have caught that. All right, a second way you can find this angular velocity is to use another expression. Omega is related to linear velocity simply by the radius. Now, we derived this expression in terms of radians. If you want it in terms of revolution, there would be a 2 pi in there. So omega in radians per second is linear velocity divided by the radius And if this is in meters per second, and this is in meters, we end up with 1 over seconds, or radians per second. So in this problem, omega will be 20, our linear velocity, divided by our radius, 0.35. And that simply is 57 radians per second. That's the easier one to get. Now, to get from radians per second back to revolutions per second, 57 radians per second, knowing that for every 1 revolution, that's 2 pi radians. That gives me 9.1, not 91, but 9.1 revolutions per second. So there's a couple ways to do this kind of problem. One, to think of this equation relating angular velocity to linear velocity, simply with this radius. And another, to think of it as kind of a ratio up here. You'll notice I'm using this style of converting things, kind of like in trigonometry and chemistry class, using units on the bottom to cancel units on top and setting up a proportion to get the correct answer.